Hello, I will be explaining the Latin square design as well as its applications to the world of engineering as well as statistics. Starting with the definition of what a Latin square is, it is a design for an experiment in which it is desired to control some two variables while investigating a third. It is interpreted visually by an n number of rows and columns arranged in a square layout. An n number of unique treatments is allowed, and none are duplicated in either row or column. Here we have a very basic Latin square design. As you can see, each row and column is filled with different letters that do not repeat. It is done to lower the amount of needed trials for an experiment. This is the only way to have a Latin square design. You are allowed to have as many treatments of rows and columns, the only rule being you cannot allow any of them to repeat in the same row or column. There are some disadvantages to this design, however. The number of levels for the blocking variable must be equal to the number of levels for the treatment variable, meaning that the square must be split into equal rows and columns, such as a 4x4, a 6x6, or a 10x10 square. Here we have the degrees of freedom for Latin squares. Due to how the design is set out, it is very easy to understand these degrees. Due to the more structured design, with there being only one observation per treatment, the model is orthogonal. This basically allows variables to be interpreted the same way, saving time. If data is missing from a Latin square, the general linear model can be used to fill in the holes. Here are some more examples of Latin squares. Take note that each design has equal amounts of rows and columns, such as the required way. Now that we understand the Latin square design, we can apply it to something that we can use like engineering. Let us assume that we are trying to determine the maximum tension of a variety of belts for an engine. These belts are made of 4 types of materials and are put through 4 different stress tests. The results can then be put into a design like this and interpreted for the results. We can determine the outcomes of the materials, compare them to one another in terms of the test that we were put under. This will allow an engineer to better pick which belt can be suited for the task at hand, while also determining the cost effectiveness of each belt. Lastly, here are the references used to gather my information. Thank you very much.